So this CodeRage 8, I was started when I was putting together this presentation. I was thinking a lot about what it means to be a developer today, and many of us have been developing for decades in some cases. Lots has changed, and you'll see that in some of the market slides we go through as well. But the thing that occurred to me as I was working on this was that it's a really good time to be a software developer. There's just so much going on. There's so much opportunity. I got a little crazy with PowerPoint animations and started thinking about the infinite possibilities that are available to you now as a developer, especially in the realm of new computing devices. So we're not just writing applications that run on a traditional desktop or laptop computer. We can write applications that run on pretty much anything and things that touch our lives everywhere and things that improve our lives in many ways. So it's just incredibly exciting to be a software developer, and especially for those of us that are love gadgets and devices. This is a really fun time to be playing with these things and doing something really interesting with them. Writing apps for them. Like many of you, I wanted to look at the market and decide what's going on out there. Why are people talking about needing mobile apps? I mean, many of you, especially those of you, as a software developer in particular, I'm sure you've had friends and family come up to you and say, have I got the great mobile app idea for you? And they're telling you because you're the guy that can make it happen. And so why are people so interested and so excited and so see in some cases a gold rush around mobile apps? What's going on out there to make all this happen? Well, probably one of the most telling things is that the world has changed to mobile. And I really love this chart because, well, for one, I was around in some of those early days and had a particular fondness myself for many of these operating systems and solutions that came through. In particular, I was a huge fan of Amiga, starting through the Commodore, and then getting into Amiga. So back then, there was a lot of choice in what you used. Now, of course, you really kind of used it as a personal computer. You had to really. There's very few things you can do with it. You were mostly tied to what you can do with it in your office or in your room or wherever it was that you were using it. And then we had this shift that lasted a very long time, the Wintel shift. And it became the predominant operating system, combination of Windows and Intel-based hardware for most of our business lives. But in the last several years, it has really been turned on its head. And what's most important about this slide is that even though Windows and the Wintel platform is as important as it was, there's several other platforms, not just one other, but at least two others that have become just as important. And that's the Apple iOS platform and the Google Android platform. So when you're building software today, if you're building it just to target Windows, you're missing a huge opportunity to get your software in front of more users. End users, customers are looking for solutions on mobile. And they're looking for solutions that cross the desktop and mobile platform. One of the anecdotes I like to share when I'm out on the road is it's a personal anecdote as a buyer of software. And how buying patterns are changing because of mobile. So some of you may know that I do some music production on the side for fun. It's one of my hobbies. And I've been using a product on Windows called Cubase for, well, about as long as I've been using Windows. It's been around for a very long time, and I really know how to use the software very, very well. And a couple of years ago, I was looking for a new mixing board, a digital mixing board that I could do more with my software. And as a drummer, I'm sitting 20 feet away from the mixing desk and behind a drum set. So if I'm in the room by myself and I need to do some recording, my only choice is to stand up, walk around, hit the record button, walk back over behind the drum set, and then start playing. And of course, I have to edit all that noise out and all that prologue and epilogue. So I started looking for software that allowed me to at least remote control the start and stop of the recording session. And at the time, there weren't very many that offered this opportunity. I mean, most of them do this now, but um, what was interesting about this is that I was willing to give up decades of experience with a particular piece of software and learn a new set of software because it offered me this one killer feature, one feature that I needed. And it took effort, and expense to make that change, but I was willing to do it in order to get this feature. And it was a good choice for me personally to move to this new set of software. But that was the kind of, the kind of thinking as a consumer of software that changed in my world. Before I never would have thought of that because one, I didn't think it was possible. But more importantly, this is the mobile world has changed the way we interact with the world around us and gives us new opportunities. And as software developers, we're part of delivering that new opportunity to end users. So keep that in mind as you're building new software and trying to engage your users and keep them happy. What are the kinds of things they're thinking about doing, or maybe they haven't thought about yet, to make their use of your software better on the desktop through mobile as well? So this is a real huge change that I think drives a lot of what our decisions need to be over the next several years. On the mobile platforms in particular, again, just tremendous change. Even just 6 or 7 years ago, there was several major players in the mobile market, and pretty quickly, this has consolidated down really to these top two players. And when I say players, I mean the operating systems, Android and iOS. I mean some heavyweights like BlackBerry, a RIM, as they were previously known, Palm devices, Symbian OS-based devices. All these have basically become almost nil in comparison to Android and iOS. So it's again a very dynamic market that has shifted towards two really primary operating systems today. And of course, there's many others that are continuing to push and try, including Microsoft, to expand their market share. So this is going to be a very interesting place to be over the next several years. Another view of the world is kind of the two heavyweights in terms of the companies. Of course, Apple sells their own devices. They're the only ones that sell iPhone devices. Samsung is sort of seen as is really the leader in selling Android devices. Between the two of them, there's been in just the second quarter of 2013, over 100 million devices, smartphones in particular, that were sold. So this is, and I think the next slide talks a little bit about smartphones in particular. As people are starting to, again, this goes on every couple of years when you're working or when you're using a cell phone, your chance to pick up a smartphone, it's easier and easier. The carriers of the world are making it very easy to get onto data plans, to get to devices that are smartphone based. And that is really what's dominating the handset world. Everybody, 78% of everybody by 2016 will be on or will be buying smartphones. So smartphones are a critical aspect of how humans are going to be interacting with the world. And it is a worldwide phenomenon. It's just, basically to think about the amount of computing power I carry in my pocket now is astonishing. I mean, even just the GPU. I was thinking about this the other day when I was at university studying computer graphics. And really the only way to do the types of computer graphics we were doing at the time was to use specialized server hardware that lived in a lab on campus. And so this was to write, real-time type of rendering algorithms, real-time in particular, which means that, of course, the scene is updated, many times a second, needed a lot of horsepower, and GPUs really changed the way that people can get access to this kind of content in more places. GPUs are just as, or in many cases, more complex, have more transistors on them, than your traditional CPU. And so, back then when I would have to either drive onto campus to build and run my app, or I'd have to tunnel through a bunch of different protocols like RLogin and telnets and, play all these games just to get my app onto this server machine living in some basement up there at UCSC. Now I can do this stuff on my phone and have incredible performance running on these devices. So it's not just the fact that smartphones do, allow for apps and allow for data, which is, of course, an important aspect of what they can do, but also just the core hardware technology that enables these things is astonishing. The price points that we're able to get these at, the fact that everybody can walk around with these supercomputers in their pockets and multi-core CPUs, and it's really just a wonderful thing to sit back and appreciate, and to just enjoy the change that's happened over time. So if we look at the tablet side of the world, this is a category that is this is sort of the gray area right now. So on one end you have your desktops, the other end you have your smartphones, and there's sort of this middle category, which, for lack of a better term, is called the tablet category. But you can see other types of devices that are vying for market share in this space, and some of them are, they're low-end notebooks or ultra mobiles. One example would be like the Google Chrome netbook, for example, and as well as the tablets that we walk around with, the iPads and the Nexus or the Kindles and these kinds of things. So tablet usage is projected to grow considerably as well over the next several years, and the primary operating system for these platforms, and again, recognize that these include not just iPads and Nexus tablets, those kinds of things, but also these ultra mobiles or notebooks. But you see iOS and Android pretty much dominating that category, and of course Windows getting some market share with their Surface products as well. So this is again the prediction for the next several years, but primarily dominated by iOS and Android. So one of the interesting metrics to look at is, okay, notebooks have been around for a long time, and they're pretty much everywhere. They're ubiquitous in the meeting rooms, that you go to. People are sitting there busy working while we're having meetings on their typing away on their notebooks. And tablets are seen as sort of a replacement for these notebooks. So it's interesting to see when this is going to happen. For years, analysts have been saying, "Oh, it's going to be 2018," and then a couple months later, because of the shipments, they would say, "Oh, scratch that, it's going to be 2017." And just this last quarter, we saw that tablets, in terms of shipments, are going to surpass notebooks this year. And it probably already has happened at this point, considering that we're now into October. So this is, we're living in one of these moments where a passage, a change, a major sea change is happening right in front of us. So as we're thinking about developing applications, again, it's not just about the operating systems that we target, but it's also how we think about delivering mobile applications. Think back to my first story about interacting with my desktop software and remote controlling it from my tablet. It doesn't have to be a full-fledged desktop application that you had built that you need to bring onto the mobile platform. It can be companion software or remote control software, if you will, to add value to your existing desktop app where you may have spent a long time delivering features and value to your customers. So there are ways to build and get into mobile without necessarily having to write the next Angry Birds and getting that into an app store and getting noticed to be successful. So think about these different ways of connecting with your user, and knowing that smartphones are pretty much all users are going to have a smartphone in their pocket. In fact, during this last launch, I went to a couple of events and asked people, what smartphones they had in their pocket, and about 50% of them had more than one in their pocket at the time. Pretty much everybody had a tablet sitting on their lap too, or a notebook. So, these devices are everywhere, and it's just going to continue to proliferate. And devices aren't, if you pick a tablet form factor, for example, it's not like you're stuck with it all the time. There's been some interesting research about when certain types of form factors or certain types of devices are more popular, or when they make more sense for an end user. And this is probably mirroring a way most of us interact with technology. In the morning, especially if you're commuting, not driving, commuting on a train or something, you're probably spending time on your smartphone looking at email, maybe doing a little browsing. But your smartphone is a good, it's a good device for the commute, or making calls, that kind of thing. Really what a phone is meant to do, ultimately. During the day, we're working on our desktops, on our PCs, on our laptops. And of course, you're seeing more and more tablet and stuff getting introduced there. When I go into meetings these days, not just here at Embarcadero, but at other customers too, you'll see your traditional set of laptops, a good mix of Windows and Apple laptops these days. But you'll also see people with their iPods or iPads and little keyboard connections for those, or some other type of tablet instead of a desktop or a laptop. I mean, this is, the meeting room has changed. Everybody's still got a device, but it's a different type of device depending on what they're working with. And this is very true for me in particular. We're getting into nighttime, done working for the day, and we kind of want to sit back and maybe do some browsing or play some games, or look up some information about a movie we're watching. This is kind of where tablets kick in, like my wife will be playing solitaire, and I might be looking up some information. Usually, I'm looking up some kind of science stuff because there's so much cool stuff on the internet about that. But it's again this sort of usage throughout the day. The type of device that we're using changes based on what kind of mode we're in and how we typically interoperate with this technology throughout the day. So there's one thing we can be sure about in the future, and that throughout the end of this year and into next, the thing that we can be sure about is that this client diversity will continue to expand. And again, when we talk about diversity, it's not just in terms of operating system. It's in terms of the types of devices that you're using. We talked about three main types that most of us interact with throughout the day. Our desktop laptops, our smartphones, and our tablets. But 2014 is kind of, I think, a year when we're going to see an understanding that computers, the way we interact with computers in other ways. So, for example, the computers in our car, our infotainment devices, the way that you interact even with your home, with home automation, or more wearable computing. I mean, a lot of us have already started wearing companion devices to our iPods or iPhones that can track our fitness. Or going beyond that, wearables like the Pebble or others that are companion devices to your smartphone. The main job there is to inform you of particular pieces of information depending on how you set it up. So you don't have to always have your smartphone out. That stays in your pocket or your backpack, and now you can interact with your watch for the critical information. Or even Google Glass, and some other types of wearables where people are connected into their into the world through this device one way or another. Another area where this is really changing is in entertainment at home, and how people collect their media and manage their media across multiple devices within their home. It's pretty frustrating when you're watching a movie in one room and you want to go to bed and finish it in your room, but you can't take that media with you. So there's been a lot of different types of devices that make it easy to stream this information to any, for lack of a better word, monitor within each of these rooms, or centralize that media so you can organize it and catalog it, and make that more available to everyone in your family. So this is just going to get even crazier. And one of the observations that I made that I think is important about this world is a lot of these devices have been around in one way or another, but they were always supported or created with at the time an embedded RTOS, real-time operating system, like VxWorks or QNX, and the use of an RTOS kind of drove the application developer to design an app that was very specific to that device. So it was really kind of a single-purpose device in that traditional sense. You put a small kernel onto the device, depending on the board and the hardware that you're supporting, and you build an app that basically delivers an experience, a very specific experience on that device. What was changing about that world is that many of these and most of these are adopting more general-purpose mobile operating systems like Android. And what Android delivers, and was largely pioneered by Apple, was a way to not only target more general purpose applications for the platform, but also a means of distribution to get that application onto these devices. So what 2014 it kind of really, I think, brings to the table is not only all these devices in ways that we haven't thought about using them before, but the fact that they're now app ready, and that you can target them with tools from Embarcadero as well that allow you to create apps that can be distributed very easily to these devices and to do things on the devices that people maybe haven't thought of yet. And you can see a lot of this in some of the, I think, really interesting things that people are doing with smartphone apps, in particular games, and interacting with the environment through a game, not just making something that's a screen and some animations, but interacting with your location, interacting with others around you, with using hardware available on these things like GPS location and accelerometers and your cameras and all these other types of sensors that give content developers innovative or ways to create innovative applications. And so that, again, this is leave it to the creativity of software developers to figure out, hey, if I bring these two sensors together, here's an interesting way to present information. We're just going to see more and more of this in 2014, more devices, app ready, and really just more opportunity. And back to the lead-in slide, it's an infinite set of possibilities for you as a software developer. There's no better time than now to be a software developer. We know this change is going on around us. It's self-evident. You're just walking around and looking around, sitting on a train and watching people interact with the devices. There's definitely a cultural shift in how people interact with technology. And it's not a Windows world solely anymore. So how are other developers viewing this change? In particular, developers who've been targeting Windows for the better part of the last 10 or 20 years. And this was a question that at Embarcadero we've asked ourselves quite a bit. So we decided to commission a study to understand the views and attitudes of Windows developers about this change. So I wanted to share some of those results with you. This was a market study we did with a local research firm here called Dimensional Research. And we told them we just wanted to, all we want to do is understand how Windows developers, those who have been targeting the desktop, are making the move to mobile. What are the top concerns for them? What's important in them understanding that they may need to do something about this? In fact, we couldn't even make that assumption that everybody felt like they had to make the move. So we asked the question, how many of you are getting requests to get onto mobile, for example? And so they asked a bunch of Windows developers. We got over 1,300 responses. And I think the results were very interesting. And so I want to share some of those results with you. The first one, which I don't think is terribly surprising, but most Windows developers have had requests to make mobile applications. And some of them are saying, and we asked, well, what kind of applications? Are you being asked to deliver some functionality of existing applications? Are you being asked to develop brand new applications? Are you asking to replicate existing desktop applications from old devices? So of course, the majority, of course, have to do something. They're being asked for me to continue buying your software. You need to get me onto mobile somehow. I need to be able to use your software while I'm at home on my tablet or while I'm on my commute on my smartphone. But we also wanted to understand, well, how does Windows fit into this world? So, if you're telling me you have to do mobile application development, does that mean you don't have to do Windows development anymore? And now, of course, we all, intuitively knew that Windows development was going to stay important. But how important was kind of a surprise. Basically, everyone told us we have to continue to support Windows. So this is, I think, an interesting perspective because as a software developer, especially one who's been targeting Windows for all these years, your world just got very complicated. Not only do you have to continue doing your day-to-day job that you're already doing, but now you have to think about mobile operating systems. So, or the other way to think about it is you're being asked to do mobile applications, but you can't just fully focus on that. You also have to support Windows. So this is, it's kind of shaping up to be a pretty complicated situation. And given that there's so many operating system choices out there, and again, this is not terribly surprising given the market share, but what operating systems did Windows developers have to target? And Android was by far number one, followed pretty closely by Apple iOS. And of course, Windows developers have had requests for Windows Phone and Windows RT and a few others, but it's really clear that Android and iOS are must-haves. And this has been something that I've been hearing from developers for a long time, Windows developers in particular, when I ask them, okay, I understand that you need to support mobile and extend your Windows application onto mobile somehow. Are you going to do Android or iOS? What is your customer telling you? And what I'm usually hearing is, oh, I can't make a choice between one or the other. I have to support both. So it's an Android and iOS problem that needs to be solved by Windows developers. So now we're talking about at least 3 operating systems that are completely different from one another in terms of programming languages and APIs and frameworks that are available to you and tooling. This is, again, pretty complicated world that's ahead of the traditional Windows developer. To further complicate this, the vast majority of developers are saying we have to go native. And now the reason why I say this is complicating is because there are technologies out there, and have been for a long time, that can democratize the application world across multiple devices. And I'm talking primarily around HTML5 and JavaScript. HTML5 and JavaScript has been running on multiple operating systems forever, as long as it's been around. That's really what was the goal of it, to deliver content through a browser, whether you're running on Windows or Mac or whatever. But what most developers are telling us is that that's not going to work for us in the mobile world. The main reason was, and I think I have a slide on this. Yes, we do. Is that there are real challenges to delivering mobile apps using these technologies. Now, if you were just delivering web content through a browser, that's fine. And I think it comes down to the user expectation of a mobile app now. When somebody's interacting with a browser-based application, there's a built-in expectation that there's going to be some latency. You know that in a browser, when you click on a link, something has to happen that typically goes beyond your device out into the cloud, pulls some data, and then paints a new page for you. So the latency expectation is kind of built into the browser experience. When you're talking about an app, something that somebody downloaded from an app store and starts by clicking an icon on their phone, the expectation changes considerably, and it's all about interaction and low latency. So there's a couple of, and for a developer, there's a couple other things that present challenges in using a scripted solution like a JavaScript-based solution. One, getting access to device features. So even though there's a lot of JavaScript libraries out there, getting access to all the features you need aren't always available to you, and you just have to wait or really understand how to write those kinds of bindings. Two, JavaScript itself, which wasn't really built to be an application language, is inadequate for most of the types of apps that Windows developers need to build. And then lastly, the performance aspect of it, this latency aspect that is becoming part of the expectation of how users interact with applications on their devices. Looking at this world that is in front of us, Embarcadero is trying to help. And with Rad Studio XE5, we feel like we've delivered an application solution to you that really nails a lot of these challenges that you're faced with as an application developer, as a Windows developer who has to get onto mobile, who has to support multiple operating systems, who has to meet user expectations around performance, etc. And this is Rad Studio XE5. So really, the premise of XE5 is that mobile is changing everything. And as a software developer, you are the agent of change. We provide a toolbox for you to approach the job more efficiently, but you are the agent of change. And Rad Studio is how we can help you create those next great mobile apps, not just for iOS, but in XE5, also Android, and of course Subtext for Mac and Windows as well. So Rad Studio 5 is really covering the core critical operating systems that we're hearing from developers out there. And the way that we're approaching it is an important consideration as a software developer, because you have choices when how you approach the problem to use tools that are provided by the operating system vendor. And they're free for the most part. But what you find pretty quickly is that it's expensive, and there's a lot of skills and knowledge that needs to be obtained and grown in order to be successful on multiple operating systems. One of the statistics that I didn't share from the survey, but I think is important to share, is that the majority of developers felt like they could not manage more than 1 or 2 operating systems effectively. In other words, targeting 3 and I'm talking about using the operating system vendor tools, trying to do 3 with operating system vendor tools most felt were an insurmountable problem. It's just too many changes, too many differences, too many code bases to manage, to build, and to manage over time. So the way that we approach the problem is what we call multi-device application development. The goal here is you use your language, the Delphi programming language or C++, you target the FM application platform, and then you build your application with the exact same source code base to create your Windows app, or to create your Mac OS X app, or to create your iOS app, or to create your Android app. So multi-device app development is not just about being able to target all of these devices from the same platform, but also to be able to do it with one source code base. And that's the critical benefit that Embarcadero brings to the table with Rad Studio XE5. And with Rad Studio XE5, the addition of Android support really brings us to, brings this solution to major operating systems that everyone needs to work with. And it also makes it capable to deal with the future as well. As we talked about, these devices that are touching our world in new ways, in many ways, that are app ready now, and most of these, in fact, pretty much all of them, are running some type of Android operating system that you can now target. I mean, this is deal with the now, which is got to get Windows, Apple, iOS, and Android, and then the future, these new types of devices that are emerging and that are likely to change our lives pretty quickly over the next several years. The other aspect that we think is a critical differentiator for how we, for our particular solution, is that we build native binaries. And this is the heritage of this company, building compilers, building very complete object-oriented languages that can be compiled down to the CPU code. And so in the realm of mobile vendors, the only other language that really does this, other than C++, of course, that runs on everything, is Xcode with Objective-C. So Rad Studio is analogous in that respect, that you take the language, you run it through a compile stage, you get a binary that you can deploy that runs directly on the CPU. And just to compare against a bunch of these other mobile solutions out there, they're basically fall into two buckets. If they're not a native binary, they're either scripted or running in a virtual machine. And so scripted is typically a JavaScript-based solution, though there are other script languages that people can use. But JavaScript-based solutions need to run through a runtime interpreter at runtime. So there's a bunch of solutions out there that are jumping on the JavaScript bandwagon and utilizing this runtime interpreter. But again, there's a piece of software now between your app and the actual CPU. And the same goes for virtual machines. Those that are particularly that use like Java VMs or even C# VMs to create bytecode that at runtime gets converted through a VM into a CPU binary. So, the core difference here is with the native CPU binary is that there's no software that running at runtime between your app and the CPU. There's no outside process that's required or that needs to be part of your solution. The way we're delivering on this is with a common compiler architecture between our C++ and Delphi languages. We generate, our front ends generate an open intermediate representation that we then use to generate through the back end either Intel or ARM CPU instructions. Quick footnote here is that C++ support for ARM is actively in work, and we're hoping to see later this year. We'll keep you posted. But the same solution that you're seeing for Delphi developers in XE5 will be available to C++ developers in the near future. So a couple of technical specifics. We're building the mobile world being a sandboxed world and has with a distribution mechanism requires the use of packages, which are more than just your binary. They also include information about how you, the types of access you want on the device or your icons. I mean, a whole bunch of stuff gets built into these packages. So, you build your app sources, you target the FM framework, and our framework, our application platform, targets the Cocoa SDK on iOS and targets the NDK on Android. And what we build for you out of that, of course, we build the native binary that gets put into this package. It's going to run on the CPU, but this gets bundled into a .app inside your IPA package. And on the Android side, it gets bundled into a shared object that lives in your APK. And so, this is the way you deliver native on Android in a shared object that gets kicked off by a small launcher that lives in your app. And then your shared object is an executable that runs directly on the ARM CPU. And so the third advantage, so the first advantage we talked about was being able to use one source code across all these devices and operating systems. The second advantage was being able to build native CPU binaries with native code. And the third one is how you build your applications. And with Rad Studio, we present really the fastest way to build apps, not just for the desktop, but also for the mobile operating systems. Some of you probably have used tools like Xcode or the Android tools. And although they provide some design elements, some visual design elements, the difference with the way you approach it with Rad is pretty starking. The Rad Studio way is that your application is basically living inside your designer, and using property method event type of model, you're able to quickly construct these applications, not just visually lay them out, but also manage application workflow, manage connections to databases, to cloud services, and all this will be driven live inside the designer. So in XE5, the designers that are available to you give you a layout, a view of the device you're working with, the resolution that you're working with, and allows you to work within the designer so that it represents what your app is going to look like and for the most part work like on the device. And it's always been impressive to do a live database connection and present that data right there in your app inside the designer. This extends beyond just database connections too. It could be any kind of cloud service. And in XE5, we delivered some new REST libraries that allow you to connect to a REST service, get that JSON packet, and quickly convert it into something that can just be visualized right there in your designer. So, talk about rapid prototyping. You're doing it right there in the designer, and you're getting immediate feedback on what your app is going to look like. You can share it with your customer. You can build them a quick app and deploy it so they can take a look at it on their device. But this approach is something that gives you a tremendous advantage over other mobile developers. Not just the fact that you can build it with one code base across all of them, but the way that you build your applications, the way that you interact with this design environment, and the framework itself. And the way that, of course, most of you who are on this call that have been using these languages know how we do this, but for those that are new, we use the Delphi language and C++. Delphi is an object Pascal-based language. Both of these languages support a paradigm called property method event. This is a way to publish data within your objects that can be presented into the designer and can be easily connected to events that you want to be able to be connected to by the end user of that component. So as we build the framework, that's how we make it available to you. And as you build out your application, to work with other developers or to build a well-architected application, you can take advantage of these great features. The other thing that we've added to the languages that really make it especially well-suited for mobile is automatic reference counting. Working on these devices with limited memory, helping you manage your memory is pretty critical. And most native code languages don't really help in a traditional sense. You create an object, you're responsible for its memory. And there's lots of ways to create memory leaks. It's really easy to leak memory. Automatic reference counting really helps manage that because unlike a garbage collector, which is a separate process and is poking into your heap to look for unused segments of memory to clean them up, automatic reference counting actually works within your application flow. If you go into a call stack or a scope of a function and you create a reference to an object either by creating the memory for it or referencing a pointer or some other type of pointer to data, the reference gets incremented. As you leave that scope, the reference gets decremented. So it's a really easy way to manage your object lifetime within the flow of your application. It's part of your application. And of course, for both these languages, there's the very modern features of interfaces and attributes and generics and collections. And recently in C++, and this has been around in Delphi for a while, anonymous methods. But one of the critical differences in these languages that enables it all is the fact that both of these languages generate such rich RTTI or runtime type identification. In other languages, you may know this as introspection or reflection, but it's the ability to query an object at runtime to find out what it's got available to you to use as a developer. And this is how we just spread this throughout the framework so that the designer can work with the confidence that it can get what it needs to at runtime, dynamically figure out what it can do to present to you all this information. And this makes the system very dynamic, and it really makes a difference in the design and development experience. And this is also something that we bring to C++, which doesn't have a traditionally strong available RTTI. All this is built into a well-architected object-oriented framework, the FM application platform, And this is just a quick view of some of the hierarchy within the visual side of the framework. But this extends into more than just UI, but data access and application logic and back-end enterprise level access to your enterprise databases, multi-tier, remoting. I mean, all these modern ways to build an application are all built into the framework. And on that note, you know, when you go to mobile, one thing that you'll quickly realize is that no app is an island. You can't just build an app that runs on the client device and does nothing but stay on that client device, unless you're building something that's like a game and really targeted towards that type of usage. If you're building a business application, you're going to need to get data from somewhere. You're going to need to interact with the rest of the world. And so really there's a couple of ways we provide this through this overall architecture we call the multi-device application platform. So from your client device, you can get to your enterprise data. You can use our data access technology on the device to talk to local databases. You can use it through middleware, which allows you also to deploy your servers into the cloud or behind your firewall or on-premise. And you can get to your enterprise data through a very rich collection of enterprise SQL drivers. And the other thing that's really been picking up quite a bit is, with cloud services is a common set of services that are collectively known as mobile backend as a service now. And one thing that's common between them all is that they all use REST interfaces. They all provide JSON data packets. They all provide common functionality, like the ability to push across multiple devices, the ability to do authentication in one portal, the ability to get to online storage that can be protected and shared, and a lot of these types of common services now are becoming part of our daily application logic. But it all doesn't live locally on the client. You need to be able to share data. You need to be able to get data out there in the cloud and from behind the firewall in the enterprise. So this is the multi-device application platform. This is the collection of objects and framework elements that we provide for you to build applications that meet the requirements of today's world. So Rad Studio XE5 really is enterprise ready through REST. Whether it's local or remote, using our data access technology like FireDAC, connecting to your SQL databases, remoting across multiple tiers, getting all this information out to multiple devices, and then building those client device applications using a native code language like C++ or Delphi is what Rad Studio XE5 is all about. So just to summarize, 2014 is going to be a very exciting year. And we're here to help you be successful in it, bringing you the ability to do multi-device, and that primarily means managing a single source code base to build native code apps across multiple platforms, including Android, iOS, Windows, and Mac. Creating true native applications. Again, these are applications that are compiled down to CPU binary code, nothing between your app and the device. So you're script-free. There's no additional application that needs to run along with your application to make it work. So you're really getting the best performance possible. The development approach of visual design, of PME, of this RTTI that we talked about, this broad framework, this really is the fastest way to create iOS and Android apps. And I think you're going to see with a lot of the demos throughout the next few days that this is alive and well in this tool, and is something that's very exciting to bring to mobile. And then finally, thinking about your app as part of this broader world, using the multi-device application platform to get the connectivity you need to your enterprise SQL databases, to build your multi-tier applications, and to easily connect to any type of REST-based cloud service like mobile backend as a service. So there you go, David. That's our opening keynote for CodeRage 8. I hope you guys enjoyed sort of this look at the market view and how Windows developers are viewing the world and what we're bringing to bear here with Rad Studio XE5. And I hope you have a very enjoyable next couple of days with a bunch of great sessions on how to be successful in this new world. David?
There's been several questions about the strategy of one code base and maybe some challenges developers will have given that there are different compilers for Delphi on desktop versus mobile, different language features, maybe some different components and so on.
Yep.
So maybe you can give everyone sort of some highlights and maybe future look and some of the things that R&D is looking at as relates to continuing to make one code base even easier and better.
Absolutely. Yeah. I mean, I think it's fair to say that we're big believers in the one code base approach. And at the same time, we also need to innovate where it makes sense when we create new platform support. So for instance, when we went to mobile, it was a good time to introduce ARC, automatic reference counting, into the language, because it really was an important language element to supporting mobile applications, we felt. With that said, and again, our championing this one code base approach, our future strategy is to unify the language across all supported platforms. So that would mean bringing back or merging these languages between desktop and mobile. So bringing ARC to desktop is another way to put that. So this is something that is, a strategy of ours, and being actively researched and developed in many cases to address this across all supported operating systems.
And today, of course, we also have support for, you can if-def code for specific platforms. You could do that on Windows versus Mac, and even different versions of Windows that you might have been using our products to build.
That's a good point. I mean, you don't have to use the lowest common denominator between them. You can, as David mentioned, use the preprocessor, do if-defs. That's one of the advantages of having compiled code tool chains, is that you can select which code you want to have compiled based on your target. So that is definitely a viable approach while we're working on unifying the front ends and the languages across all these platforms.
And there was a question in the same vein about what might happen to ANSI strings. Would ANSI strings go away in favor of standard string? Of course, we have Unicode string across all the platforms. That's just the string type.
Yeah, I mean, again, we want to simplify the usage of the libraries. The strings in particular have a long history, and so we want to get down to a string that makes sense for all the platforms. Yeah. Absolutely.
Yeah. There's been several questions about the fact that we've shipped multiple releases over the last year, and that we live in right now a quad platform, I guess quad platform, and who knows other platforms that are talked about on the roadmap, like Linux Server, WinRT ARM, and so on, about what that might mean for the cadence or timeframes of releases in the future, and how should developers think about and plan for that kind of activity of updating in new releases.
Yeah, it's definitely something that's important to think about, because we've had to be aggressive about putting out multiple releases to support these important operating systems, to continue to evolve the framework and the language to meet the needs of this changing landscape. And even despite the fact that there's other operating systems, the fact that we're on iOS and Android, those are pretty dynamic worlds in and of themselves that are on completely different schedules from one another. So I think it's fair to say that we're going to continue to have rapid releases, meaning more than one per year. And we're going to do this to allow developers to stay current on these new operating systems and these new features that come out when they do. My advice would be to look at software assurance as ways to manage, especially the upgrade costs of new releases, but also to think about your project development a little bit differently in terms of looking at how you build applications, how your schedules work, how your features work, using more frequent release cycles yourself, which could make a lot of sense also in this mobile world.
People have been reporting some different issues they've been having with some of the recent releases, issues, crashes, bugs. I know we've done updates. R&D is always looking at updates, of course, again, with the cadence of new releases because of platform changes. We could sneak updates into those platform support releases as well. I constantly tell people, put things in Quality Central, report issues or problems you're having, try to keep track of what you were doing. If you can't capture a sort of crash or specific kind of problem.
Absolutely. We always want to know about any kind of issues that are affecting your productivity. In particular, on the runtime side, if there's something that's preventing your app from doing something that it needs to do, we want to know about it. So QC is probably the best way to get to us. Also going through support if you have a support contract. They can escalate issues to us as well. We do meet regularly and look over issues, and we do plan those for updates and or releases. This is part of our standard development approach. We've also been in a cycle where we've been really pushing hard to enable a lot of new technology. And with the release of Android, a lot of that heavy lifting has sort of been completed. And so this is a real good opportunity for us as a team to also go back and look at some of the other issues that may be getting in, that may be preventing you or getting in the way of your productivity. So let us know about these sooner rather than later, and these are something that we can probably spend a lot of time on here in the near term.
Okay, and I know we're over, but I'm the next speaker, and I'm going to do some demos with FireMonkey on iOS and Android. So There's plenty of time to do all that. I want to make sure that we get through some more of these questions. So everybody, don't worry about the schedule. I'll just talk faster during my session. Let's see. A couple of people have noted they were looking at mobile support and they wanted to be able to do database programs for mobile. And we've shown people in videos and launch and articles how to work with SQLite and our own IB Lite and Interbase to Go. We have sessions in CodeRage for those things. Some people are wondering why they can't build a mobile app that talks directly to SQL Server or Oracle or something like that. And I always point people to the fact that, well, Microsoft doesn't deliver SQL Server client libraries for iOS and Android.
Right. And that's part of the reason is that generally our drivers talk to the local database driver, and many of those are not available on mobile platforms. But the bigger issue is that the way that a mobile device interacts with the network is a lot different than traditional desktop or laptop. Your traditional desktop or laptop, you can be pretty confident in your connection. It's also usually within the network. And so you can make certain assumptions about security, about network availability that makes client-server connections a very viable approach. And we've been doing this for a long time. When you get onto the mobile devices, you may not always have that connectivity. It's very easy to just walk 10 feet and lose your connection. You may not be behind the firewall, although you get VPN access on a lot of these devices. You may not always be able to be in that VPN. And again, this goes back to some of the network support. So client-server does not make as much sense. Having a direct connection to your database from a mobile device on a carrier network has flaws in that approach. So I would encourage you to look at other ways of getting data to your desktop. This is why middleware is so critical, or has become such an important approach. Again, we've gone through middleware cycles in this world, but for mobile in particular, this allows you the ability to manage data across tiers, where you can build in, the ability to make sure that that data is flowing well, that you're reconciling appropriately, and that you can deal with things like network outages or pushing data from behind the firewall out to something that may be on a public network. So that's it's a combination again of the availability of the technology, but also just a difference in the paradigm of how one should consider working with databases from a mobile device.
Yeah, there's been several questions about can we do anything more with our technology partners to convince them to build mobile support for their component sets. And I'll answer that, and you can chime in as well. We've been working with all our tech partners for years, going way back to a year and a half, even before XE2, where we talked about different options we had moving into the mobile space and off just Windows only, and also what decisions that we were making with FireMonkey to be the solution and the architecture to build on multi-device. And that some of the technology partners like TMS Software has moved forward very aggressively with their products and new products in the mobile space. And that there are others that are still taking a look, and they love to hear from all of you that are out there that there's a business opportunity and that you want these pieces and parts. Mm-hmm. Some of them now are more interested. Once it wasn't just Windows and Mac, that was XE3. Now that there's iOS and XE4 and Android and XE5, they're getting more excited. So it'd be a good time to go back to them again and to encourage them to now add support for doing mobile development in Delphi.
Yeah, that's pretty. I mean, really, what can we do? We can ask you to convey to the third parties that you care about and rely on that you're committed to this this approach and this framework, and that you need their support as well.
Because some people are concerned that ANSI string is going to go away. We haven't dropped ANSI string.
No, we're not going to deprecate anything as well. Yeah. I mean, we have a very good history of supporting technology, even though we may have a preferred approach to move forward. You know, I'll put it this way: BDE is still shipping in the product, so don't get worried about that kind of stuff. We will listen to what you need. If you need that for code compatibility, we'll make sure that you have it.
Yeah, ANSI string is still there. I do think Unicode string is the universal string type for building apps that are going to run all over the planet Earth. Yep. I mean, there's still work to be done. There was a question about Hebrew, Arabic, and so on. Right to left, BiDi support. We've had meetings to talk about how we can add new capabilities for localizing and for specific languages. Right?
Oh, absolutely. Yeah. I mean, that's something that we're actively researching.
I don't know. There's so many questions. There's some specific ones. Some of these will get caught up after the fact. People come back to questions several times about WinRT and WinRT ARM support. Mm-hmm. I know those are mentioned on the roadmap.
Yep.
And of course, with Microsoft, next year going to be completing the mobile acquisition of Nokia, mm-hmm. and putting more resources into growing mobile.
It's definitely something that we are keeping a very close eye on and also working on. But, looking back at the survey, it was clear to us that Android and iOS were the must-haves. And that's what we're delivering. And where it goes from there, again, depends, one, on what you need to be successful. But also, we're looking at the general market as well. Microsoft is successful with their mobile strategy, then that becomes a very likely target for one of our upcoming releases.
Well, some people are asking, what about VCL into the future? What about VCL on multiple platforms and such? And VCL is Windows only,
VCL
right?
will continue to stay a Windows only framework. We've been adding features to it, by the way. Maybe we haven't been doing a good job of marketing that. But a lot of the stuff that we're enabling in FireMonkey, we're doing at a low level that benefits VCL as well. So a couple of examples. We did all the sensor work to enable mobile. All of that's available to you in the VCL as well. We've done FireDAC, this new data access technology that we've made available not just only for FireMonkey developers, but also for VCL developers, and has really great performance and great features. Another example is this REST service that we've been working on. So these are libraries and features that we are adding, not just to FireMonkey, but also to VCL, because we're doing it at I wouldn't say an RTL level, but a lower level than just FireMonkey. And as much as we can, we want to share that technology across both platforms. But to be very clear, VCL will stay Windows, I'll say WinAPI specific. VCL will stay WinAPI focused, whereas FireMonkey, the FM application platform, is how we're targeting and managing multiple operating systems and devices.
Okay, there's some things here specifically about performance comparisons, and so I've encouraged everyone to send us, put into QC or whatever, if you're comparing, for example, one platform versus another, performance or size of executables, performance using Java JDK or the Java SDK on Android versus the native SDK. And please give us those, pass along those examples of what you're seeing, so we can either explain how to take advantage of, for example, the GPU support that we have for doing certain operations like image effects and things of that kind, versus what you might be doing somewhere else using a different library.
And more than just code examples, how you're setting up your project. This backend is highly optimizing backend, but it's also very sensitive to the optimization level. So a debug mode, for example, with no optimizations, is going to be slow, and that's the nature of that kind of binary. And there's a stark contrast, much more stark than it was on, say, DCC32 on Windows, between a debug non-optimized binary and a fully optimized release binary for this. So make sure that you're doing your optimizations and so that you really can see the best performance possible out of your builds.
So Warren was asking about VCL and FireMonkey integration on Windows. Stephen Ball and others have done videos and articles back in the days of even XE2 and XE3 about how you can put forms in a DLL, FireMonkey forms in a DLL, and then access them from VCL. You could also even put a FireMonkey form in your executable and just make sure that you call that form directly. There's no auto create and other types of integrations. You can't parent a VCL form inside of a FireMonkey form. You can always parent a FireMonkey form inside of a list box item, for example. Everything can be parented, but there's nothing we're going to do specifically for doing more integration between VCL and FireMonkey. We're really focused on FireMonkey for multi-device and VCL for Windows.
And then again, where you're going to see us sharing technology will be at the library level, like we've been doing for the last several releases. And there'll be shared technology between them. It doesn't mean that the UI elements between them are going to necessarily be compatible or supported, but we do. Again, we are trying to make common functionality available to both as we go forward.
Yeah, and that's anything in the system namescope can be used in VCL and FireMonkey. So system.sensors that JT mentioned, all the sensor interface, you can do that in your VCL apps, as well as you can do it in your FireMonkey apps. So take a look at anything in the system namescope, especially some of the new things that have been added, and you can use those in both VCL and FireMonkey.
Indeed. And
I've got a Samsung Slate Series 7. It's got an accelerometer. It's got a light sensor. It's got a bunch of different bits in it. And these kind of hybrid or 2-in-1 is one of the terms people are using now, desktop notebook. So you've got all of that stuff. JT, thank you very much.
Yeah, thank you, everyone.